All right, we are going to compare functions. So let's say that I have an equation that says negative 9x plus 3y equals 27. And then another equation that I have is negative 3x plus 4y equals 24. Now, I'm not going to actually solve for my variable. What I'm going to do is I'm going to rearrange, so that's why you need to see the first video. I am going to rearrange the equation in order to get it into slope-intercept form. Slope-intercept form, in case you've forgotten the 100 billion times I've said it, y equals mx plus b. That is our slope-intercept form. So I need to get this to look more like this. So let's do that. We're doing the exact same steps we did in the previous video when we had to rearrange in order to look at our independent variable. So I need to get y on this side by itself. The first thing I need to do is take the inverse of my x. Bring down 3y, 9x plus 27. Now, where did I get plus 27? Because this is a positive. So I just took this 9x and I put it here. This is a positive 27, so I just put positive 27. Can I combine a 9x or a coefficient that has a variable with a constant that does not have one? No. All you can do is put them next to each other. Not as a multiplication, just as, hey, whenever I find out what that x is, then I'm going to add. But until then, you don't know. So what is keeping my y value from being by itself? What is in the way? This is in the way. So the inverse of this is a division. And what I do to this side of my equal sign, I have to do to the other side. To everything on the other side. 3 divided by 3 is just 1. So I would have 1y or just y. 9 divided by 3 is 3, and I keep my x. 27 divided by 3 is a positive 9 because I don't have any negatives. So this is the equation I have for my first one. Let's look at the second one. I need to do the exact same thing. So everything I did over here, all of the steps I did here, I need to do over here. So I'm going to get 3x on the same side as my constant so that I can isolate my coefficient and my variable together. Uh-oh, we're gonna run out of space. Let me scoot that over a little bit. Scoot that over. 4y equals 3x plus 24. Divide everything by that coefficient. I end up with y equals 3/4 x plus 6. So, what is my slope? What is my slope for this one? And what is my slope for that one? Y equals mx plus b. My m is this one right here. So if this is my m on here, then that means this is my m on here. So the slope on this one equals 3, and the slope on this line is 3/4. Which one is bigger? Which one has the greater value? The greater rate of change. Which one is changing faster? 3 or 3/4? Well, think about it. If I had $3 and you only have 3/4 of 4/4, which would give me $1, you have 75 cents. I have $3. Who has more money? And there you go. That would be me. Okay? So once you rearrange the problem, just like we did in the other one, that was the precursor, like the preview, before the coming attraction, which is this, comparing your functions. So now you see how to compare the function. This is just one example. We still are going to look at another example. Okay, we're going to look at another example. So I'm going to erase this. You can go ahead and take a screenshot if you need to before I erase it, or pause it and take a picture, because I'm going to erase. Okay. Now some of these notes you should already have, but what I will do is I'll hand write some notes and I'll post them up with like I normally do. Okay. So let's do y equals 3/5 x plus 2. And then this next one, I'm going to do points. So 1 and 2.6. 3 and 3.8, 5 and 5, and 7 and 6.2, or 6 2/10. Wait a minute, Miss T. Wait, you're not giving me the equation. No, my friend. You need to solve to get the equation. So what you gotta do is you gotta use, let me get my smaller one. For this one, we gotta do m, our slope, equals y2 minus y1 over x2 minus x1. And hopefully you remember that because we just did those a few weeks ago. And we've been doing them for like the last 2 weeks. So let's get to plugging them in. I'm going to use this set of points and this set of points just because they're my first two. So if this is my, let me use black, x1, then this is my y1. And if that's my x2, this is my y2. And we're going to substitute them in. So I have 3 and 8/10 minus 2 and 6/10 divided by 3 minus 1. y2 minus y1, x2 minus x1. So what am I going to get? Well, 3 and 8/10 minus 2 and 6/10 actually gives you 6/10. 3 minus 1 gives you what? 2. Let me check my math. That doesn't seem right. I don't think that's right. I didn't do that right. This is why I need to write things out, because doing it in my head doesn't work out. 8 and 6, 2. Aha. I knew something wasn't right. So that doesn't make any sense, Miss T. 3 and 8/10 minus 2 and 6/10 is 1 and 2/10. That's why when in doubt, write it out. So am I done? No, I'm not. You got to actually get a 1 underneath. So if I do 1 2/10 divided by 2, I'm going to get this. Now let's look over here. Are they the same? Well, this is a decimal and this is a fraction. So you have two ways you can do this. You can turn this into a decimal, or you can turn this into a fraction. Let's just turn this into a decimal. Trust me, it's way easier. What's outside the house stays outside. What's inside the house goes in. I'm telling you, sometimes even Miss T is like tripping, straight tripping. So what is outside my house stays outside. I went ahead and put him inside the house. What's outside on the porch stays out on the porch. What's inside or above goes inside. Okay? So I guess I could say what's above goes in, what's below goes out. I don't know if that's confusing. So how many times can 5 go into 3? None. So when you have that situation, remember, you need to add a decimal and add a 0. Now I can say 5 can go into 30. How many times does 5 go into 30? It goes in 6 times. So the slope here I forgot I was using a different color. So my slope over here equals, and my slope over here equals, this one is 0.6, and this one is 6. They have the same exact slope. So when I compare these two, can I say that one has a greater slope than the other? No, I cannot. They do not have different slopes. Their slopes happen to be exactly the same. So the comparison really is not necessarily a comparison because they are going at the same rate. Their rate of change is the same. They don't have a different rate of change. Now I do not have, well, I think I don't have a grid down here. Maybe I can use a grid. So I can show you another one. When you have a graph, it's kind of hard to show though. So I don't know if I'll be able to get to that. But you're going to do it the same way. If you see a graph, so go back to when we used a graph to create an equation. So use a graph when you have, let's just say you have this as a question. Use the graph to make your equation. Now, normally they'll give you an equation and they'll give you the graph. So if you already have one equation, then all you need to do is find the equation for the other line or linear expression. And then you take that and you compare the two. Okay? So as I said before, if you have questions, please ask. I am available from 9 to 1 if you have a question. And some of you email me outside of those hours, which is fine. I will still respond as I have been, okay? My official hours are 9 to 1. If it's after 9 p.m., Miss T is not going to get back to you until the next day, hun. I'm sorry. I got to go to bed at some point. But I will get back to you in the morning. So don't think at any point in time you cannot ask me a question. If you send me a question at midnight, when I see it in the morning, I will respond to you, okay? Take a screenshot if you need to. Pull up some of the notes that I have already on Google Classroom. I will probably take a picture of this one and upload it to Google Classroom unless I decide I'm going to, yeah, I'm going to do that. I'll take a picture, upload this into Google Classroom, and then the other one that we did before this one, I'm probably just going to rewrite it and upload that one just as a frame of reference for you. The other notes that I'm talking about, when we had to create an equation based off of a graph, based off of a table or a set of points, those notes are already on Google Classroom. So you may have to do some digging for the last maybe 2 weeks. It's all there. I do not feel like uploading the redundant notes. They're already on there. Okay. I will say, okay, hey, look through Google Classroom. It's not going to be far. It'll just be in that classwork section. But literally go back to some of the other notes that we've done. Go back to some of the other videos. They're still available for you. You can still look at them. This is not something that's going to go away. So I don't want you to look at it and be like, oh, I don't care about that. I don't need to worry about that. I don't need to. You do, boo-boo. You do. You need to worry about this. This is definitely something you're going to see again. And I do not want you to be ill prepared. You have to be prepared for 9th grade. Because you need, in 9th grade, you start earning credits in order to graduate. You need this to earn those math credits so you can graduate, okay? If you have any siblings or if your parents understand it, hey, let them sit there and watch these videos with you. You know, you guys can work on it together. If you have anybody that you can help, I mean, call each other and ask each other questions. Definitely don't go to each other's houses, but you can FaceTime or Snapchat or, I don't know, Instagram Live, something. Just reach out to each other and help each other out. There's nothing that says you cannot do that, okay? So best of luck to you guys for this week, and I will see you next week.